group decided we were going to do environmental impacts.
Oh, cool. That seemed like a great idea. The seems like there's more than there's a couple different angles on that too. So absolutely. So are you thinking about the mining cost or what other things that sort of come up?
So pretty much it was, yeah, like the mining costs and different power sources and stuff that can be used for it, since a lot of it that we've found is pretty negative because it's such a high cost. It produces a lot of CO2. So just different ways that they're working on making it more energy friendly and making it so that it saves the earth rather than degrades it.
Okay. So a couple of things that crossed my mind. The Lightning Network uh, that I did a short video on last night. Sorry, I thought I'd get it done last week, but I ended up making a bad recording. I had to redo it. Is an example where hopefully most of the transactions end up going off chain, like they're not recorded in the blockchain. And so it could be true that really kind of the core, that doesn't suggest changing the core protocol for Bitcoin, but it does maybe mean that a lot of the transactions are environmentally much cheaper. Another one that's related is Ethereum. We talked about Ethereum, and they're going through a fork which does two things. One is it does a sidechain thing, kind of like Litecoin, to increase the number of transactions. But more importantly, for your point of view, is they're switching over to more of a proof of stake versus a proof of work version. So the amount of computation that the miners have to commit is substantially lower. So that might be some interesting, I don't know, places to think about. Guess I don't know where you really find estimates for this, but there's a significant amount of energy spent on traditional banking resources, right? The energy spent to mine and store precious metals that are used, for value, and the environmental impacts of the mines themselves. Certainly in Colorado, we see a lot of that side effects. So that might be an interesting other thing to sort of balance it against, that there's cost to the traditional sort of sense of value as well. And that might be interesting to talk about. Okay, anybody else? Sorry, Eric, I thought you were going to say something. It's hard it's impossible to read people's faces because nobody's faces is up.
Yeah, sorry, I don't have any questions.
Oh, okay.
I'm just taking notes.
All right. So send an email. You have enjoyed your last short quiz, and then I guess there is going to be one long one, and we have it's obviously not going to be in class, and so the details of that I guess we're figuring out. But it'll be like a long quiz is the plan for that. So going over the old quizzes is a pretty good idea in preparation for that. I imagine we'll do it at the same time that the usual final is assigned. And I actually don't remember when that is. We can look it up if you want. But we'll probably just administer it during that time. And that seems like about it for sort of class notes. So I have been working on something related to what's called BIP 39, the brain wallet idea. And so I thought it might be interesting to demonstrate some of that stuff and some of the ideas behind it. And it's not only to do with Bitcoin. It's actually kind of convenient for other purposes as well. But the connection is this thing called brain wallet and the idea of using passphrases for security, and then having ways to have recoverable passphrases. And again, we talked about this kind of on a whiteboard version of it with a Shamir secret share. And you can use it to do things like protect wallets and create keys, create Bitcoin addresses and that sort of stuff. But you can also use it for kind of anything. Like if you wanted to create a password that you wanted to have safe, in the sense that if you shared it with a few friends or relatives, some subset of them could get together to recover the original secret, which could therefore be a key to whatever it is you want. That's the core idea of the technique. And so there's some software that I've been building related to that. It's available, and I think it might be interesting to just sort of see a little bit about how it works. Does anyone else have any questions before maybe going into a little talk about this idea of Shamir secrets? Okay, so let me just give this a shot. And let's see, I'm going to switch over to my my whiteboard just for a couple minutes. And then there we go. Okay, so the idea is, it's kind of cool. Like, it feels a little bit like magic, but the idea is the mathematical thing is a Shamir secret. Try again. And you can create your own secret, or you can let the system create a secret for you. But the idea is you have a secret, which you can think of as like a passphrase or something like that. At the mathematical core, it's really just a number, a large number, but you can represent that number in different ways. And then from the secret, you choose a certain number of minimum keys. So you like key 1 out to key n. Let's say, I don't know, I guess I'll stick to n. So you make a bunch of keys based on the key on the secret. And again, really, these are numbers also, as far as the math is concerned. But you can think about those numbers as phrases or passwords or things like that, and convert them into numbers. And then, so you start from the secret, you can generate the keys, and then what's cool about it is, let's say, and then you can pick some subset. So at least, so if you have, I guess, n of them there, at least m, which is any number you want to pick, so long as it's, not, between 1 and n. So 1 less than m less than n. So you pick as many as you want, you choose that ahead of time. But if you pick at least that many of those, then you can recover the secret. So let me see if I can say that a different way. You start from the secret, which is just generated at random if you like, and that's actually one of the safest way to do it. And really, and you choose the minimum number of keys that you want it to work with. And then you can generate as many keys as you want with that fixed minimum in mind. You have to obviously have to at least m of these keys for it to really make any sense. What the idea then is that if you have that many keys, you can then recover the original secret. So if you had, I guess your parents and like a sibling and yourself, that'd be 3 people that all could hold a key. And then you could say, well, okay, I'll make 2 out of 3. So I'll set up a Shamir 2 out of 3 key. And then if any 2 people get together, they can put the keys together and recreate the secret. And that way, what's nice about that, you can have a secret that like you can erase, right? So you can create the secret and then really just destroy it, and just make sure the keys are around. When the keys are around, you can recover the secret. But what's nice about it is now the secrets or the keys can travel in different directions. Just maybe a piece of paper, or one in the bank, and one with your parents or something like that. And that way, it's both secure and it's safe, because if there's no reason for someone to want to break into your safe to take a key, because a key by itself isn't any use. You need all of them before you can recover the secret. And so that's kind of the math behind it. Then the next part is really like thinking about how these numbers work. So the numbers can be converted back and forth to different, maybe useful representations, so that you can more easily share them. So, for example, you can have a phrase in different languages. You can have a phrase in different languages, and you can have sort of a compressed version of it, like a QR code, or some of the other ones. I guess those are a few of them. So let me just show you a couple of demonstrations of how this works, at least with this bit of software, and kind of how you could use it. So let's see here. So right now it's not very pretty. It uses what's called a command line. But it depends on very few other pieces of software. Sorry. Slide this in here, and then try to demonstrate how this works. So the project itself is a public project. Anybody can get it. Oh, sorry, let me switch to the screen share. All right. So as a project, it's hosted on GitHub, which is it's the same place where like the Bitcoin Core is hosted, but it's where many people manage software projects from. So here's the software, and then some basic directions on how to use it. And so let me just demonstrate the basic idea. So here's a place where it's at. Okay. And so if I wanted to say create the shares that we are just talking about, I can do something like, it's called Brain Wallet. And say I wanted to make how many shares. This is the total number. So if I wanted to make, what would you say, 3 out of 5? So make 3 shares where you need a minimum of 2 of them to recover. And then I'll ask the system to just create a random set of keys and shares. And that again is the safest choice. Oh, except I need to spell minimum correctly. Aha, interesting. All right. Let's switch to an older version. Okay. So here's a request for, and this is one of the release versions. So the previous version is a working code. So here I've asked for a total of 3 shares, minimum of which have required is 2, and just ask for a random version of them. And so here they are in English. Turns out that the safety behind them, the default is 132 bits. So guessing one of these secrets is as easy as guessing 132 coin flips, is how that comes down to, which is essentially impossible, computationally impossible. And so here they are. So this is the secret, this phrase right here, okay? And then here's the corresponding 3 keys, all right? And they can be represented in different ways. So like I was saying before, so if I say language equals Spanish, this will generate a new set of random keys, but now the words are in Spanish instead. And so the system supports a few languages. So Chinese, English, French, Italian, Korean. And so let's just try Chinese simplified just for fun. I can't read Chinese, so I just have to assume that this is correct. So here's the secrets in Chinese. So the idea is to make this something that humans can use. And so the words are things that people in China could write down and remember. You could try to commit these to memory. There's 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. So you have 12, in this case, Chinese words to remember, or just write down and store in a safe place. So, so those are the secrets, all right? And so the idea then is, let's go back to English because I'm assuming most of us are not that familiar with Chinese. Oh, just leave that out. All right, so then the idea then would be to take like these words, print them out or write them down in some careful place. And then, send them off into different places, maybe electronically or pieces of paper, whatever, smoke signals. Wow, I'm getting an awful lot of phone calls from places I don't understand. Huh. Okay. So, so then the idea is, so here is the minimum equals 2. So now, eventually, right, as the world goes out there, I could just set up the same thing. So you do have to remember how many shares there were and what the original minimums are. So you should write that down. And you do have to remember which keys are what. So you have to write down that this is key 2 and like this is key 3. But let's say that this is, at some other place and time. Say instead what you have is just key 1 and key 3. Oops, no, actually use something and then ask for the secret. Like that. So hopefully, so here's the original secret when it generated it originally, right? But then using the brain wallet idea, you can ask to recover that secret from the 2 keys, one and casino, the key that starts with 1, the key that starts with casino, and it recovers this this key. And so if you if you have the wrong keys, so I don't know, so I just changed one of the words in there, then that Greek, that is not what I expected at all. Remove attacked. Key 3. Key 1, key 3. Oh. Huh. Well, that's a quite funny moment right there. Well, so if you don't have, sorry, I'm running into a mathematical impossibility in my head right now about how that could have possibly turned out. Key 3. Oh, huh. Well, if you don't have the minimum, it's not like you can figure out. That's a, trying to understand how that could possibly be true. Key 2 equals, and key 3, huh. Sorry, I'm still trying to get my head around how changing this one word ended up still recreating the same key. I don't see any differences in that one. Huh. Okay, I'll have to think about that. But essentially, the idea is if you don't have the contents of the key, and you you would not guess 132 bits of everything else in that key anyways, you cannot recover the original secret. And so here is a key recovery system. So you can send off the keys to different people, and the recovery just can be done at any other time. And without the original keys, you cannot recover the original secret. Okay, so there's a little bit of, I guess, cryptography. You could use those secrets in things like the Electrum wallet. Like this is suitable for creating brain wallet style keys. And therefore perfectly good for different kinds of cryptocurrency. But you could also use this for whatever, right? This could be a passphrase that unlocks kind of whatever you want it to, right? And so it is a nice way to allow people to share secrets in a way that's recoverable and safe. All right, I think that's what I have for today. And if you had any questions about it, then happy to talk about it. All right. I'm going to stay on board for the rest of the class, but if you guys are done, that is totally fine. You don't certainly have to stay and listen. I'll just stay in case somebody else comes in and has some questions for their projects. You guys have a good Monday.
Yeah, you too. Thank you.
Hi, I'm struggling to I was trying to find like a worksheet or something to get a better idea of like all the requirements of the final exam or like the final project.
Okay, that's a good question. Dig around a little bit.
And so we're encouraged to look for like partners to work on this project as well.
Oh yeah. And there's a forum. Where in the heck is our? Huh. Sorry, our syllabus got lost in the so many start here links now. I mean, where did it go? Sorry, I'm lost in trying to follow links. Students, course schedule, course syllabus. There it is. Wow.
Oh yeah, you're fine. I was kind of going through the same thing.
Okay. That was pretty hard to dig up. There's so many links in that start here section. But there's a section on the final paper. Let's see if this seems pretty reasonable. So 15 to 20 pages, double spaced. So it is encouraged to be groups, right? And then the idea is if you have 3 people, then everybody really has about 5 pages. So we asked that they be approved. And then the description of the contributions, and you get a bonus for turning things early. So what were other questions? So I guess the title page and references count towards, that was a question that came up.
You said that there's a forum available, and like, is there just like a discussion board? Is that where like people are looking for partners?
Yeah, I'm not saying. Right here. You can see this, right? Oh, you can't. I am, or wait, can you? Did I do a screen share? I believe I did a screen share.
I apologize. I can see. I just I was looking through my phone. It was like a lot smaller than I was expecting. I'm not wearing my
Oh,
glasses.
sorry. Okay. But I mean, if, and then just do it that way. If you go through assessments on the D2L thing,
Okay.
then there's a final paper teammates forum. And so that's
Okay. Okay, sweet.
That
Thank
was
you
the
so much.
idea behind that one. And I know that's not as easy as just meeting up with everyone and talking, but I was hoping that today might be such a day, or just earlier. So, but this is a forum that might help you find a teammate or teammate.
Okay, sweet. That's really helpful.
Okay, and then in the syllabus, there's a brief description of what we were looking for. So I think that's that's the core outline. Is that good?
Yeah, that answers my questions perfectly. Thank you so much.
Okay, you're welcome.
Well, hey, thank you for your time. You have a great day.
Yeah, you too.
Bye bye.
Oh, please go over the final quickly. The idea of the final is going to be just like a big quiz. More or less a mashup of the quizzes. And you'll be taking it roughly in the same way that you've taken the other ones. It's just gonna be long. I think that's the main point. Okay. And and Alfred left. So there's a summary of the chat question. All right, that's everything for now. I'm gonna not bother recording a bunch of dead air, but I'll stay here for a little while in case someone comes in.
All right. Thank you.
Sure.